So, I welcome every one of us to IO Academy, and today we'll be doing DET 207 Applied Mechanics. So, under this one, we are familiar with what we call vector and scalar, right? You know that anything vector is something that has both magnitude and what and direction. And those things that don't have magnitude, that has magnitude but without direction, are called scalar quantity. So today, under this vector, we are dealing with what we call resolution of what of vectors. Resolution of what of vectors now. And resolution of vector is talking about you converting forces, like you want to do resolution of forces, resolution of like no force is also a vector, right? So we want to convert force that is in a resultant form into what into its composition component from resultant to what to component, that is the vertical component and the what and the horizontal component. And under this one, under resolution of vectors now, we have the resolution of vectors now. Okay, using force as the scale as the case study. Now we have resolution of vectors now. Under this resolution of vectors, we have what we call triangle law. Triangle law, that is using triangle, and under this word, we make use of when you have this, having this now, this right angle triangle. Okay, we can call this one A. So I can call this place Y. I can call this place what X. So is that what A squared is equals to what S squared plus what plus Y squared. I know we are familiar with this, are we? And A will now be what the square root of what S squared plus what plus Y squared. And we also have what we call parallelogram law. Parallelogram law. So in parallelogram law, we have this. Um, we have something like this, and the diagonal represents the resultant. This is just introduction. I'm still going to do some things there. So we have this place can be, let's say this place is U and this place is V. So we can have an angle like this between them, between this place. If this place is V, this place is also V, right? If this place is U, this place also what? This place also U. So this place is U and U, this place is V and V. So we can just put this here. So that this place and this place are equal. This side and this side are also equal. This side and this side is parallel to each other. This side and this side also parallel to each other. So this place is represented and called 180 minus what? Minus theta. This place also what called theta. Such that what? This side and this side are what? Are the same. So if I put something like, if I draw something like this, if I draw the parallelogram like this, so I can just make a sketch like this. So this side and this side are the same. This place and this place are theta. And that's what we call what? Corresponding what? Corresponding angles. Corresponding angles. So and this law now is called, this one here is called Pythagoras theorem. Pythagoras theorem. So this side and this side are the same. Now, what I want to also talk about, I want to talk about using, we also have what we call polygon word. We also have polygon, we have polygon law. We have what we call polygon law. In this aspect, we make use of this place. We know that this place is positive x-axis. This place is what? Positive y-axis. This place is what? Negative y-axis. And this place is what? X as negative x-axis. So we can have forces lying in this form. We can have forces here like this, like this, like this. Is that taken? So we can call this one what? F1. So the angle that this one is making with the horizontal, we can also call it what? Theta 1. Is that clear? So we can call this one F2, right? So the angle that this one is making with the horizontal, we can also call it what? Theta 2. So we can call this one F3. The angle that is making with the horizontal, we can call it what? Theta 3. Now, this one, F4. The angle that this one is also making with what? With what? The horizontal. Now we're just making mention of horizontal to make it easy. But they can still make angle with what? With vertical. Is that clear now? And we can still calculate it and we still get the same answer. But me, I want to, for introduction, I just want to make use of what? I want to make use of using what's it called? Horizontal. Is that clear to you now? Though this place will now be, if you want to make use of this side, this will be 90, Abi, minus what? Theta 2, right? This place also what? 90 minus what? Theta 1. Is that clear? Because from this side to this side is what? Is 90 degree. And we know that if this place is theta 2, Abi, and this side is what? Theta 1, they must give what? 90 degrees. Such that if you bring this one to the back of this one, it becomes minus, Abi. Therefore, we have theta 2 as what? 90 minus what? Theta 1. So this place is theta 90 minus theta 1. This place is what? 90 minus what? Theta 3, Abi. And this place is what? 90 minus what? Theta 4. So, because of that, so so I think we can put it down. You can put it down. You can snap it on your phone. You can snap it on your phones. So um, let's look into all these ones there. So we have, according to the polygon law, the polygon law actually states that the adjacent side of a parallelogram represent in magnitude and direction of what? Of the two forces, that is the two forces that are acting at the same point. You know, the forces are acting here, they're acting at the same what? Same point. This is V and this is what? This is U. They're acting at the same point. So the two forces that are acting at the same point, the adjacent sides of what? Of the parallelogram. That is the adjacent side. What do I mean by adjacent side? This side and this side. Is that taken out? Or you know they are also acting at the same point here. This is V and this is U. They are acting at the same point here. This is V and this is U also. They are acting at the same point here. Abi, this is what? V and this is U. Acting at the same point. So this now is saying that what? If two forces now acting at the same point, the adjacent sides of the what? Of the parallelogram. Is that clear now? This side and this side, or this side and this side, or this side and this side, or this side and this side represents the two vectors in magnitude and direction, such that the what? The diagonal cutting through the what? The line of the action of the two forces represent the what? The resultant. So this line now, this is the diagonal. Is that taken out? In all the meaning of diagonal, when you have like rectangle like this, and you have like a line like this cutting it from this side and this side, we call it what? We call it the diagonal. Is that clear now? We call it diagonal. We can also have it here also. Is that clear to you now? This is also what? This is also diagonal. Is that clear now? So now this line now is also what? It's also a diagonal. So let's move on. So now we have some questions here. But in this one, I've not written out the formula. You know, I gave us the formula for this Pythagoras theorem. So let me also give us for this one. So before I give that, let me just clean this one up. So let me just clean this one. So now, if I have this, let me make it very big. Let me make it very big. Okay, let me call this place U, and let me call this place. Let me just represent it as what? V. So let me make it like this. So there's angle between here and here, right? Let me call it what? Theta. Don't forget, both this side and that side are also what? Are the same. This side and this side, all these sides are the same because they are corresponding angles. Is that clear? Don't forget this side and this side is the same thing as what? U. This place and this place are also what? Are also V. But I told you that the angle between this one and this one is theta. You can also have another angle here, and let's call it what? We can call it beta. Is that taken out? We can call it what? We can call it beta. Now, this place is the resultant. So if you want to find the resultant, we are going to make use of what? Cosine rule. Cosine what? Cosine rule. That cosine rule is saying that if you have a squared, then you are going to have what? B squared, abi, plus what? C squared, abi, minus 2. This is B and this is C. BC. Is that correct? Cos what? Cos 180 minus what? Theta. Is that taken out? So we have a squared. If you look at it, you are not having anything like a in the formula because already a is what? A is already here. So we have a squared is equals to what? B squared plus what? C squared. Then B 2 minus 2bc. Is that clear now? Cos 180 minus theta. Is that clear? So that is it. But if you are having your theta, if you don't want this minus to be there, you can just use what is given to you directly. So that we have what? A squared is equals to what? B squared plus what? C squared plus 2bc. Cos what? Cos theta. Thank you very much. Cos theta. So let's say we have this. I think we have given a force here. They say this is a question here. They say force P and Q act at point 0. The magnitude of P is 10 newtons, and that of Q is 15 newtons. The angle now between P and Q at their point, okay, of action is 50 degrees. Find the resultant force. So we need to find the resultant force. So we are doing that forces, that is P and Q, act at point 0. Okay, the magnitude of P is 10 newtons and that of Q is what? Is 15 newtons. Now, they say the angle between P and Q at their point of action, this is the point of action, is that taken out, is what? Is 50 degrees. Find the what? The resultant force. So that is that. So you can clean this. So then we have this. So the angle between them, this is, let's say this is P, right? And this is what? This is Q. So the angle that is lying between them is what? Is just 50, right? It's 50. Don't forget this place also what? This place also 50. So according to what we normally say, we say angle between what? Angle on a straight line is what? 180, right? So if this place is 50, this place will be what? 130. Thank you very much. 130. So this place is 130. Okay. Okay. I've called this one P as what? It's given as what? 10. So it's given as 10 newtons. And Q is given as what? 15 newtons. Is that clear? So we are going to put our resultant between them. So this is the resultant here. So I told you that you can either say, let's say you can say r squared is equals to what? Is equals to 10 squared, right? Abi? Plus what? 15 squared. Is that taken? 15 squared. So if it is plus that you want to use, that means you want to use this 50 direct. Is that clear to you now? That you want to use that 50 direct, the 50 between them. But if it is minus that you want to use, then it means you want to use this what? 130. Is that clear? Please put it at the back of your mind. So if it is this plus that you want to use, just put 50 direct. So we have plus 2 into what? 10 into what? 15. Is that taken? Cos what? Cos 50. Cos 50. So then you have r squared. So this is 100, that is 10 squared, it means 10 times 10, right? Okay, that is 100. 15, that is 15 times 15. I think this is 225. Okay, 225 plus 100, that is 325. So we have 325 plus. Then this one times this one give us 20. Have we 20 times this one? 300. Have we? 300 cos what? 50. So in a calculator now, you can just search using this. We can find cos what? Cos 50. Cos 50. Okay, so we have 325 plus. So cos 50 now times 300. So I got 192.836. So let me just make it 4, right? So if I add them together, what did I have? 715.84. So newtons. So r squared. So let me just remove the newtons first. So let me take what? The square root of both sides, right? I'll take the square root of both sides. So I'll take the square root of both sides. So we have r is equal to the square root of what? 517.8 what? 4. So what do I have? So if I take the square root of both sides, I will have 22.756. So let me just make it what? 76 newtons. Is that taken out? So let me re-explain again. So according to the cosine rule, we have, if it is a, we have a squared. What we follow will be what? B squared, C squared. Then you pick the 2 again. Is that clear now? So if it is plus that you are using, you have 2 what? B, and what? C, cos what? Cos theta. Is that taken out? But if it is minus that you are using, so we have a squared is equal to what? B squared plus C squared minus 2BC cos what? 180 minus theta. Is that taken out? So if it is minus that you are using, then you put what? You will have 180 minus what? Minus theta. But if it is plus that you are using, you just put what? Cos theta. Is that taken out? You just put cos theta direct. Now, if you look here, I use r. This is r squared. I pick what? 10. That is 10 squared. I also what? Pick 15. Is it clear now? Then I told you that here we have BC. Look at the BC. Look at 2 here. This is 2. Let's say this is the B. That is 10. And this is a C. 15. Is that clear to you now? Then what follows what? Cos what? 50 using the first one here. Is that taken out? So I just use that like that. Then this is r squared now. 100 squared and 15 squared. When you just pick your calculator and press 100 squared plus 15 squared, I think it should give you what? 325. Is that clear now? Plus, now this is 2 times 10, gives you what? 20. So 20 times 15, I think it's what? 300. So this is 300 here. Cos 50 now, look at cos 50. So your calculator just press 300 cos 50, it will give you this. This one is this one. This plus this plus. Is that taken out? So when you add it together, it gives you what? 517.84. All right. So this is r squared. So according to the conventions in mathematics, when you have square here, is that clear? You can cancel this square by what? By half. You know when you have 2 like this. If you have 2, hello? If you have 2, you can cancel out these 2 by what? By using what? Half. Is that clear to you now? So this is 2 times 1. It gives you 2, right? When you cancel out each other, it gives you 1. Is that clear? So, and you know that half is still the same thing as what? Square root. Is that clear to you now? So if I have 25 raised to power half, it's still the same thing as what? Me having what? Square root of what? 25 as what? As 5. Though we can sometimes put plus or minus. There are some times we put plus or minus. So that is that. So now, me using the second one. Let's use the second one. Is that clear now? And the second one, in the first one I used this 50. The second one I will use what? But I will put what? Minus. I must put minus there. So let's move on with that. So the second one I will put I say r squared, Abi, is equals to what? Is equals to 10 squared, Abi, plus what? 15 squared. But this time around, I will put what? Minus 2 b. What is b now? Is this 10, right? So 10 and what? This what? 15. Now, cos what? 130. So now, so we have r squared is equals to, now this 100, Abi, we keep it outside, that's 100, 10 squared, that's 100, Abi, and this is 15. 15 times 15 give us what? 225. Is that clear now? So 100 plus 225 give us 325. So now, look at this. Press your calculator, minus 2 into 10 into 15 cos what? 130. Let's press it. Let's press it. So we have minus 2 times 10 times 15 cos 130 give us what? Gives me 9 plus 192 points. Make sure you put the minus first. Okay. So it gives me 83.836. So I will approximate and get this. So we have r squared is equals to this. So I put square root to both sides, having 517.84. Is that clear? Then I will have what? R is equals to 22.676 new things. And if you look at it, we still have the same what? We still end up with the same answer. So before I move on, I want to ask, maybe there's anybody with question. If you have question, let me, maybe you want to ask a question. Is there any question before we move forward? No question, you all understand it. So if you are with your phone, you can just snap it. If you go, you can go through it and write. So if you have your phone here, snap. You can snap it, go home and write it. And if you have questions, ask questions so that we can what? We can deal with it. So now the other things I want to make mention here is this. If you look at this place, you see that the angle between this side and this side is just 50, right? But I can still the angle here. Is that clear now? We can represent with anything. We can represent, this is just alpha. You can put what? Beta there. You can put gamma there. Anything you like. Is that clear? Even you can put George. You can put George there. Is that clear to you now? You can put F. You can put Akmen. You can put it there. So to represent what you want to do. Now, before we move forward, I want us to find out alpha. Is that taken now? I want us to find out alpha. Are we ready? Okay, let's make use of this side. Let's make use of this side. Now, if I have a parallelogram like this, I have a parallelogram like this form, I know that this one, this side and this side are what? Are corresponding, Nabi? English student. Something corresponding means what? As if they are facing the same side. Facing this side, another person is standing facing that same side. So their angles are the same. Is that clear? So now, if this side now, we have it as what? As our resultant compared to that one. So this side, let's say is what? Is alpha. So we can represent with beta also. So now, let me cut this side. Is that taken? Is that taken? So I've represented this side. Look at here. From here now, look at here to here. Let me call it what? Let me call it. Okay, let me just call it V. Is that clear? And let me call this side what? U. Don't forget this place also what again? It's still U. Because this side and this side are the same. So this place also what? V. But you know that here and here is just V. But there's this space here. Look at it. Like there's still something here. That is from here to here is V. From this point to this point is V. But there's still something here. Is that taken out? So, and if you look at this one, it looks like what? Like triangle. It's actually triangle. Right angle triangle. Is that clear to you now? And I want us to open our eyes very closely or openly. I want us to open our eyes. This place is U. So we can resolve. This is the hypotenuse, right? Let me just bring it out like this. Let me bring it out like this. Can the camera reach that side? Okay. Is it reaching that side? This side. Is it? Okay. So now, we have this. And this is what? U. And this is what? The angle. The angle is made with the what? With the horizontal. So this angle here is facing this side as the what? As the opposite. Okay, let me just make the assumption. I will prove it for you. So this side, this is U here. So this will then be U sine theta. Is that clear to me now? This is U also. This will be U cos theta. So we can prove it by this. So this is what? Opposite. So we can have sine theta, right? Is equals to opposite. You don't know what is there. So let's just say opposite. Over what? Hypotenuse. So cross multiplying this one time this one. So you can just put this one over one, this one time this one time this one. So we are opposite is equals to what? U sine theta, which is the same thing as this. Is that clear to you now? So we have cos theta also. Cos theta is what? Car. That is adjacent over hypotenuse. Let's say arch. Adjacent over U. So let's cross multiply this one time this one and this one time this one. So adjacent is equal to U cos theta. Is it clear now? Is it clear? Very good. Very good. So now what we are going to do now is this. What we are going to do now is this. If you look here, let me just use this side to finish that work. You can now see that this place will now be U cos what? Theta, I mean, and this place will be what? U sine what? Same time theta. So therefore, now what I will put here is this. If you look here, you see that it's like another triangle is also formed. Abi? It's as if another triangle is formed, such that what? We have something like this. We have something like this. Yes. This is the I. But at this point, there's a point here, such that this place, the first place is what? Is V. And the second place is what? U cos theta. So it will be plus. Is that clear? We add it together. This side will now be what? U sine what? theta. So the angle here is what? Is alpha. Is that clear? The angle here is what? Is alpha. So now what we're going to do is this. We have to find this one, the angle between this one and this one. So what are we going to do? We are going to make use of tan, that is opposite over adjacent. So we have tan alpha is equal to what? Opposite, abi? Over what? Adjacent. This is what? V plus what? U cos theta. So now we can finish it by saying this. By saying what? Tan what? Oh, sorry. Alpha itself is equals to arc tan, which you normally call what? Tan inverse. You can call it arc tan. Is that clear? So we can call it arc tan as U sine what? Theta over what? V plus U cos theta. So that is that. So that is how we do about that. So once you keep doing it, you keep doing it, you keep doing it. You know, this may be your first time seeing something like this. When you keep doing it, you'll be what? It'll be part of you. There are sometimes you just see a question, you don't need to, you just look at it. You just write out the answer, and you work it. Is that clear? Please, let's keep doing it. So now, what I will do to this one? What I can do to this one is this. I know that since this place is given as 10, Abi, this place is given as 10. I know that this place also was given as 10. So this place will now be what? This place will be what? 10 sine what? The theta here is what? 50. This place will be what? 10 cos what? 50. So what are we going to do? We are now going to say tan alpha, Abi, is equals to what? Opposite. Is that clear now? 10 sine what? 50 over what? This place is what? 15, Abi? 15 plus what? 10 cos 50. Cos 50. So now, what are we going to do? 10. So we have 10 sine 50 give us, give us 7.6604. And this is 15 plus this is 6.4278. So then let's just convert that 8 to what? As 1 and add it to that 7, making it what? 8. Abi? Or we should write everything out. That's 8.